So let's take a look at this physics entity. We say here that we need a body representation in our physics simulation. This thing in itself is also something that we need. It's known as a world within Box2D. So there's a Box2D world. Now let me introduce you to a pattern that we'll see pretty much everywhere with Box2D. We have the B2, this specifies Box2D. Then the type of thing we want to make. In this case, I want to make a world. So I specify world. And then to make any of these things, we have these definition objects. So I'll call this my world def, and then assign it a value. It's again B2 for Box2D, default. So we have this default here, and then world definition. So with our world def, we can specify the gravity. This is going to be a B2 vector, not the SF vector there, but we can initialize it the same way. I'll be explicit about this. I'll set my gravity to nothing, so there's no gravity here. This gives me my configuration for the world. I still need to actually create the thing, and then I want some sort of handle that I can use to query that world. And with this, again, it's B2 world, the thing that I'm working with, ID, this is the handle type. I'll call this my world ID, and then B2 create, and then finally the type of thing that I'm creating. Takes in an argument. This is a pointer to the world definition. So pass in the address here, world def, and there we go. Now I have my world ID here. One thing with Box2D is we can perform some cleanup with all of this stuff. So just to get into a good habit of cleaning up my resources, I'll say world, I'll say a B2 destroy world, and this takes in a world ID. And that'll take care of cleaning up this world here. All right, so that takes care of our physics simulation. Now we need to get this body representation for our north wall. And following our pattern here, it's going to be, again, a B2, we need a body, so it's going to be a body definition. I'll call this my north wall body definition. Then again, I need to create one of these definitions. So there's going to be a default body def, like that. The body in a Box2D represents the configuration of what kind of a physics entity this is. So it doesn't tell us anything about the shape or the geometry that it occupies. It's simply the type. Now, because we're dealing with walls, these are going to be static. They won't move. They won't be affected by anything colliding with them. So on our north wall body definition, we have this type field. And then the options we have is going to be static body, dynamic body, and this one is affected by collisions and forces, and then kinematic body. This thing isn't affected by forces and collisions, but it does move around. So it's sort of something in between dynamic and static. For our wall, though, we want to go with a static body. And we also need to position this. So north wall body definition dot position is going to be at the meter representation of where we put this. So if we take a look at this, we could run it through our converter here, or we can simply do the math ourselves. So let's see here, 400 divided by 50, that gives us 8. And then the 25 here, that's half a meter. So we can do half a meter here. That should take care of the position. Now we have our body definition. Following our pattern again, we have a B2 body, and this time the ID, so the handle. I'll call this my north wall ID. Then it's going to be B2 create. And then the thing I'm making, so body. And then I just need to pass in the correct argument. So we need a world ID for this. And this means that we could have multiple worlds running in parallel with each other. within the same program, and they all have their own bodies existing in them. So this takes in that world handle that we have, our physics simulation. And then the next thing is going to be a body definition address. So we'll say the north wall body definition here. This again is a B2 resource, so we can have a destroy body method call down here, and we simply need to pass in the ID. So that takes care of our body representation. The next thing we need is a shape config and geometry. So there's a B2 shape definition, north wall shape definition. And this is again a B2 default shape def. This shape definition is the configuration for this shape. So it tells us how the shape is going to interact with things in the world. It doesn't actually tell us the position or the geometry. For that, we'll need something else. We don't really need to worry about anything here, but just to give you an idea, we see here there's some stuff for density, and then also some of the more important things is going to be these sensor events and hit events. We also have this is sensor down here. So this tells us how this thing works in the world, but we still need to give it the geometry, and that is done with some specific types. So we have special or very specific types for these things now. In the case of a box or a wall, we have this B2 polygon, and I'll call this my north wall geo. To create these, we need to say B2. And for a polygon, we can actually use this box type here. Takes in a half width and a half height. And we can actually take this here, the position, because this is the half width. It's telling us that halfway point is going to be 8 meters. That means the whole thing is going to be 16. The half height is going to be 0.5. That means the whole thing is going to be a full meter. So now we have these two things. This is our shape config and geometry. We now need a shape ID. So we'll have a north wall shape ID. And this time we don't have this create shape, but rather we say B2 create. Then we tell it what kind of shape we're having. So polygon shape. And then, well, the shape keyword or the shape word of that method name. And for this, because a body can have multiple shapes, we give it the body ID. So this north wall ID. Next up is going to be this definition. So north wall shape definition. And then next is the geometry or the polygon there. So we say north wall geo. This gives me a shape ID. Now this is again a resource, and we can clear this. So B2 destroy shape, pass in the ID, the handle, and then update body mass. I'll pass in false there to speed this up. If we pass in true, then it will calculate a new mass for this body based on the destroyed shapes. But there we go. This takes care of the shape config and geometry. And now we have this. Up next is going to be simulating this whole thing. Now currently there's nothing happening, but we can call this so long. Drawing our geometry, drawing our graphical representation should happen after all of the things have updated. And to update the simulation in Box2D, we have this method. So we say B2 world, and then we have a whole bunch of stuff in here. But the one we're interested in is going to be step. So this will simulate the world. We need a world ID here to tell it which one it needs to do it for. The time step, this is what dependent on the frame rate. We set the frame rate to 60. That means our time step will be 1/60. And we can actually make this floating point values. And then the sub-step count, this is pretty much always just 4. Sort of like the resolution of your physics simulations. All right, let's run this. And we won't see anything happening. because there's no other physics entities in here. But let me set up a southern wall, the south wall, and that's going to actually be pretty easy. We can just copy and paste all of this stuff here. And then instead of north, so I'll click on all of these values here where I have the word north in them, like that, north, 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 north. Let's see here, anything else? North there. If I replace this with south, that's it. The position is going to be 8, so the middle of my world. But it's not going to be at 0.5. It's going to be at 12 minus 0.5. So we can actually make this 11.5. I'll be at the bottom of the world. Let's see here, south wall, this is fine. The geometry is fine. I need this to be 8 and 0.5. This thing is going to be placed at 550. So it's 600 minus the 50 pixels. The origin, we can set this up, and then finally we need to position this thing. We'll place this at 550. Last thing I need to do with this is to actually draw the south wall. So I run this, and it'll show up down here. Looks a little weird, but that's fine. So there we go. Up next, we'll make our ball and set it up with some impulse to see that the physics simulation works with our walls. So let's take a look at that.